let's do our first example of trig sub, which is the shorthand for trigonometric substitution. So I've got 1 over x squared, square root of 9 minus x squared dx. Okay, so when I look at this particular problem, what I see is a square root and I see a number minus x squared. So if I take a look over here, that looks like pattern number 1. But it's something squared minus x squared. So the first thing I need to do is rewrite this in a meaningful way. So I can write that as 3 squared minus x squared. Okay, so that tells me that my a is 3. So then I can refer to my template and say, okay, well if that's true, then x is a sine theta. So that's going to tell me x is 3 sine theta. That gives me that dx is 3 cosine theta d theta. And then I have that the quantity here, 3 squared minus x squared, is 3 cosine of theta. Alright, so now doing that, I can plug in and let's see what we get. So I get 1 over, well, x is 3 sine of theta, so I'm going to put 3 sine theta squared, and then this is 3 cosine theta, and then dx is 3 cosine theta d theta. Okay, so now I have everything in terms of my thetas. But I have a 3 cosine theta on top and a 3 cosine theta on bottom, so that makes my life a little easier. That just gets me 1 over 3 sine theta squared d theta. Now from there, what I can do is I can square that 3, that gets me a 9 sine squared. So that's 1 over 9 sine squared theta d theta, which I can then write as 1/9. So I have 1 over sine squared left, but 1 over sine squared is cosecant squared theta d theta. So hopefully you remember, but you may not, that the antiderivative of cosecant theta, or cosecant squared theta, is negative cotangent theta. So I have negative cotangent theta plus c, or negative 1/9 cotangent theta plus c. Now, I have an issue because how do I get, I've got a cotangent, I need to get back to x's. Well, there's a couple of ways to do this. So this is one of the reasons that I really like advocating for the triangle method, because if you construct your own triangle, this becomes easy. So let's take this triangle here. Right? That is my triangle for this. So by constructing a triangle, I can say, all right, cotangent of theta, well, tangent of theta is x over this square root. So cotangent is just this over x. So I get negative 1/9 times square root of 9 minus x squared over x plus c, which I can then rewrite as negative square root 9 minus x squared over 9x. Right, and that's my answer. Now, if you don't have the triangle handy, the easiest way to do this is to just go back to sines and cosines. So I could say it's negative 1/9 cosine theta over sine theta plus c. And then what I would do is I would go back to my original construction. I would say, okay, well, cosine of theta is this thing over 3. So that's negative 1/9 9 minus x squared over 3. And then I know that I don't actually have sine of theta, or I do have sine of theta. Sine of theta is here, so sine of theta is x over 3. So that's on bottom, so that becomes 3 over x plus c. And then I can cancel, and I get the same answer. I mean, you're going to get the same answer, but the idea here is if you go to the triangle, when you have the trig function, you can always just work your way exactly backwards from it and pull the values you need.